All right, today we are going to learn about our systems of equations. Now, there are going to be three methods that we are going to go through. There's the graphing, substitution, and elimination. This video is going to be in a couple of parts because it will be going through all three, and it will be broken into at least 2 or 3 different videos for you to watch. So go ahead and write down your system or your essential question. How can I use each method to solve a system of equations? As we are going through this video, please make sure to pause at any point that you need to be able to either follow up with what is written down or to practice on your own and come back and check your answers. All right, here are some of our vocabulary words. We have systems of equations. This is 2 or more linear equations. So we are going to be taking what we learned in our last unit with linear equations, and we are going to put 2 or more together to see where their point of intersection is. So the solution is the ordered pair that makes the equations true. So if we graph, we're going to find where the intersection is. We are trying to figure out what one point makes both or all of the equations true. Consistent, that is where your system of equations has at least one solution, and it makes it either independent or dependent. Independent means you have exactly one solution. Dependent means you have infinitely many, meaning that you are working with the same line. And inconsistent means that there are no solutions, meaning that they are parallel lines. The 3 type of methods we are going to be looking at today are graphing, finding the intersection. And then if there is one. So with graphing, it is just like what we just did. We can graph it from any of the type of equations, be it point slope, standard, slope intercept, and you are looking at where the 2 lines cross. Substitution method. This is when you can very easily quickly solve for one of the variables, be it x or y, substitute it in and solve back out. Elimination is where you can easily eliminate a variable to solve. You can use any of the methods. Graphing can be used literally for almost every single one. Sometimes it's a little bit harder when it comes to the fractions or decimals of the equation. Um, Substitution is one that you can use for all of them. Elimination is one you can also use for all of them. But you'll see kind of which kind of equation makes it a little bit easier for each. All right, we are going to get into our graphing. So again, if you are not done with this stuff, you should be pausing and going back. So when looking at these 2 equations, I'm going to graph them as is because this is going to be our refresher on how to graph lines. So this first one is in the form y equals mx plus b. So in this one here, my slope is negative 1/2, and my b is at the point 0, -4. So I'm going to start with that. So I'm at 1, 2, 3, 4, and I'm going to use negative 1/2. Well, that means I go down 1 to the right 2. Now I can't go any further, so I'm going to go backwards because I need to be able to kind of have a look at where my points intersect. So I need to put possibly more than just our normal 3. So up to the left, up to the left. So there is my first line. Now, I'm going to use a different color for you to see it. This is in standard form. So I'm going to solve for my intercepts. It's going to make it a little bit easier for me to be able to just quickly graph. So my x-intercept is at negative 1/2. Okay, so whoops, it's not negative. Negative 1/2. And my y-intercept, negative 2y is negative 2, so y is at 1, so up 1. Well, that doesn't really help me, so let's go back and I'm going to actually solve. So this is how you can solve your intercepts. I just wanted you to do that refresher piece. But now I'm going to go back and I'm going to actually solve for y in order to figure out what my slope is. Then divide by -2, divide, and divide. So we got y equals, this turns out to be 2x and then plus 1. All right, so my slope is 2, which is the same as 2 over 1, which means I go up to the left. Well, I have my 1, right? So I'm going to ignore this x here, and I'm going to go backwards. I'm going to go down to the left. Sorry, up, right, down, left. So down, left 1, down, left 1, and that is where they intersect. So that is my solution. So I graphed both points. And then from that graph, I went and saw where do they intersect. So they intersect at this point right here. So what I'm going to do is I'm going to pull out what is that point value. My x is -1, -2. And my y is -1, 2, 3. That is my solution. You're looking at for which point do they intersect at. So let's try it again. All right, so this first one, all I have to do is real quickly move my 2x over. So I can pull out b is 3 and slope is -2, which is the same as -2 over 1. So that means down to the right, or if I go backwards, up to the left. So start at 3. 1, 2, 3. Down to the right, down to the right, down to the right, down to the right. Just doing lots of points in order to see where they will intersect. All right, I'm going to take a new color. And it might help you if you use different colors while graphing. Now, 6 doesn't go evenly into 16, so I am going to solve this for y. If this was, say, like a 2x and I could easily divide out my x and y, I would use the intercepts. But in this case, I'm going to solve for y in order to get an accurate slope and y-intercept. So I'm going to take away 6x. I'm going to divide by -4. And I get y equals, this turns out to be -4. Negative divided by negative is a positive. And 6 divided by 4 reduces to 3/2 x. All right, so I start at -4, and my slope is 3/2, which means I go up 3 to the right 2. So let's start at -4. 1, 2, 3, 4. All right, here we go. 1, 2, 3, 1, 2. I only had to graph 2 points for that one because we already see where it intercepts, and that's what we're looking for. So this point right here. So this is at when x is 1, 2, and y is -1. So my solution, 2, -1. This is what we are looking for. Which coordinate point makes both statements true? If I plug back into -1, I get 4. Take away 1 is 3. Correct. 12 plus 4 is 16. Correct. So when I plug them back in, it makes it true for both statements. So the graphing shows you the visual reason behind what we're doing. Now I'm going to show you some other methods as well. But first, I'm going to show you what a no solution looks like and what an infinitely many looks like. All right, so this first one, I can actually easily solve this top one for my x and my y. So I'm going to go down here. 2y is 2, so y is 1. So that means I can do my y-intercept. And then my x, -x is 2, so x is -2. So right there. All right, that is my first graph. Now let's graph the other one. Blue. All right, so I start at 1, 1, and 1/2 means I go up 1 over 2. Or let's go backwards, down to the right. Oh, what do you notice? they are the same line. So because same line, infinitely many. So when it becomes the same line, you get infinitely many solutions. So let's try the next one. The next one, this first one, has a setup at 1, 2, 3, and then 3 for the slope here means I go up 3, 1, 2, 3 to the right 1, up 1, 2, 3 to the right 1. All right, so there is my line. Now the other one, use orange. If I divide by 3, y equals 3x minus 3. You know what I'm going to do? Let's change this. Let's go plus 3 here, plus 3 here, because I want to show you what no solution means. So change this to a positive 3 and a positive 3 here. So we're going to start at 3. 1, 2, 3. All right, so I cannot go up 3 to the right 1 here. So we're going to go backwards, down to the left. So down 1, 2, 3 to the left. 1, 2, 3 to the left. What kind of lines are these? They have the same slope and different y-intercepts. What kind of line? They are parallel, which means no solution. So when you get the exact same line, they are infinitely many because all points match up. When you get same slope, different y-intercept, like the orange and the green, it means that they are no solution because they will never cross. All right, so that was graphing. Let's go into substitution. Whoops. Okay, so I want to make this a little bit bigger. Okay, so substitution. What your goal is in substitution is to get either the x or the y all by itself for you to be able to substitute it into the other equation. So when I look at these two equations, I have x plus y equals negative 32. Well, neither one is just x equals or y equals. But our first equation has it says y equals 3x. This has it where y is by itself. So what we are going to do is we are going to take and substitute it into the other equation where we see y. So instead of this y here, we're going to take that out and put in 3x. So now I'm left with x plus 3x is negative 32. Now solve for x. So this becomes 4x is negative 32. When I divide by x, or 4 I mean, I get x is negative 8. So that's my x value and my point. So I know that x is going to be negative 8. Now I'm going to take that x value of negative 8 and I'm going to put it into the first equation and solve for y. So y equals 3 times x. And in this case, our x is negative 8. So y equals negative 24. So our coordinate point answer is negative 8, negative 24. So in this case, this would have been harder to graph because we would have had to have a very big graph in order to make that work. So again, you need to get it down to either y equals or x equals, and then substitute it into the other equation. So let's look at what's on the left here.